Question 1. What is the difference between matched pair data and independent samples? Okay, the matched pair data is the data that we talked about in the last section. And remember, it's really important that the rows, the numbers in the rows, match up. For example, they belong to a single person or a single household. So maybe it was John's pre-test and John's post-test. It's important to keep his two scores together. His scores are matched versus maybe Sally's scores right here. There again, it's important that these line up. That's matched pairs. It could also be maybe husband and wife in the same household. It's important to keep the husband and the wife together, that they don't get mixed up. Okay, so that's matched pair. The two scores have to align. Now, in independent, that's not the case. This is more when we're comparing two groups. So, for example, maybe it's boys versus girls. And so we have, let's say, running times. How fast can they run the mile? And so you may have one boy here that runs it in 7 minutes and one girl here that runs it in 6:45. And you may have, lots of other times. Then down here you have a speedy guy that can run it in 5:30, and you have a really slow girl that runs it in 18 minutes and 9 seconds. Now, it doesn't matter which order these go in. It could be switched. The 18 could be up here and the 5:30 could be here. So the important thing is that if it's matched paired, then what row it is tells you what should go there. So that's the difference, the main difference. A few examples of the main differences between matched pair and independent sampling. Part 2, question 1. What is the research question? All right, the research question is there a difference between the mean wages of boys and girls at BYU, Idaho? Are the boys making more than the girls? Are the girls making more than the boys? Is it different? That's all we want to know. B, state the null and alternative hypothesis. Okay, so the null hypothesis is going to say that mu m is equal to mu f. Now, these little symbols may change. You can put whatever little symbol you want. You can maybe say mu1 and then mu2, but they just represent the two different groups that you're comparing. And so I chose M and F for male and female. So the null is that they are the same, alternative being that they are not the same. Okay. Collect the data. Describe the data collection procedures. Students from one of the math department's professor's class took a survey. And so this isn't a simple random because it's just all of the students of one professor. Okay, problem 3. Describe the data in a short paragraph. Use summary statistics to describe the data. Okay, well first let's open up the data. We will be working with the class survey. So we're going to open up the class survey. And what we're going to do here is first analyze the data using just our descriptive statistics and explore. In our dependent list, we'll have the wages. And then in the factor list, we'll have the gender. Okay, if we go under statistics, 95%, and we don't have to worry about any of that. Okay, so we open it up here, and you'll notice that first they do the female statistic being, or the female mean being 9.76, the standard deviation 3.1, and then your N, your sample size being 91, found in that box, and then the information from the males as well is right below it. Okay, and then in order to make our graph, we're going to go to the graphs up here, legacy dialogues, down to histogram, And in the histogram, we're going to put in the variable section, we're going to put the wage, because that's our variable. And then in the row section, we're going to put the gender. Hit OK. And that'll open up our nice little histogram right here that you can copy and paste over, representing the data. Question 4C. Compute the test statistic. Okay, now in order to compute the test statistic, we come back up to the Analyze, Compare Means. So Analyze, Compare Means. And then we're going to go to the Independent Samples t-test. Now, the test variable is the wages. So we're going to move the wages over. And then into the grouping is going to be gender. Okay, and then under the Define Groups section, under Group 1, we can title it, I'll just title it M for simplicity, F for female. We'll hit Continue, and then we can click on OK. So this should give us the following. Yeah, here it is. Here's our statistics again, the group statistics. And then down here we have all of our information. So if we open up our class survey, you can see in this column B we have all of the gender, and they have it organized so that the females are first, which is nice. So I'm going to highlight down until we get to the males. There's quite a few females, 96 females. So I'm going to copy that data and bring it over to our quantitative inference. Now make sure you've selected the two-sample t-test, not to be confused with the paired sample t-test. This is for matched pairs, this is for independent. So right now we're working with independent. I'm going to put females first. I'm going to paste that into there, and I'm going to come back and grab the rest, which are the males. Should take us to the end. Okay. We're going to right-click. We're going to copy the males over to column 2. Paste. Alrighty. Okay. Now, in order to find the appropriate statistics, these are given to us, luckily, right here. So if you notice, variable 1 remembers females. So we have the female mean of 9.7 was the average, and 11.9 for the males. And then this with a standard deviation of 3 and a standard deviation of 10 there. Now, in order to make the histogram, we can do the histogram. Remember, every time you're going to do a histogram, you can just come in here to the quantitative descriptive statistics and copy and paste your data right into there. Oh, this is the QQ plot, so you can make sure you get over here to the histogram. But very simple, just paste it in. Here's your QQ plot. We have most of our people making here in this range. We have a few outliers over there making an extreme amount. And then in order to grab the females, we can just come back to our first column, which is where we had put the females, and copy and paste them over into our histogram. So first we want to clear the contents, make sure, especially when you have a lot of data going in. Oh, it looks like that. Copy. So let's try this one more time. Copy. And then we're going to paste. Okay, so here's your second histogram of the wages of females. Part C, compute the test statistic. Now this we'll do over here on our Excel. we have our test statistic is simply given right here with the t equal to negative 1.836. Okay, and again, this could be plus or minus depending on whether you put females in variable 1 or females in variable 2. Either one is acceptable. Okay. Part D, state the degrees of freedom. The degrees of freedom are right next to the test statistic, right there. The p-value is next to the degrees of freedom with 0.96, or let's see, hold on. There we go. Okay, so that's a good thing to remember. Make sure to hit not equal to on the type of test because we're doing a two-sided test, and so it's not equal to. And that's what we had decided from the beginning. Okay, so not equal to, then it gives you an appropriate p-value. F, make a decision. Do you reject the null hypothesis or fail to reject the null hypothesis? Okay, because our p-value is just barely bigger than our alpha, we will fail to reject the null hypothesis. Remember, the catchphrase is, if p is low, reject the null. Well, p was not low enough, so we failed to reject the null. G, present your conclusion in the form of an English statement. We have sufficient evidence, we have insufficient evidence to say that or to suggest that there is a difference between the mean wages of boys versus girls. Okay, so insufficient because we failed to reject, and then restating the alternative hypothesis. Part H, rather than testing a hypothesis, now say you just wanted to estimate the difference between female and male wages at the 95% confidence level. This is also given on the Excel sheet, the quantitative inference procedures, right here in the bottom right-hand corner. So we know that there's a difference of -4 to 0.1, and you'll notice that 0 is included in that. So we're not confident that there's even a difference at all. I. Now interpret the confidence interval you built above. Okay, so now with this confidence interval from -$4 to about 18 cents is what I had on mine. And remember, it might be switched and the signs might be flipped as well. So you could have from, let's see, what would it be? From -18 cents to +$4. But what that means is that we are 95, from our little sample, we can say that we are 95% confident that upon the whole campus, if you were to question every single person on the whole campus, we can be 95% confident that the true difference between men and women is somewhere between that -4 and 18. So we're basically 95% confident there isn't any difference.